Here we go, Modern Thought, Part 3. We left off here when we talked about Emil Durkheim as one of the leading founding figures in modern sociological thought, sociology itself. And another one is this guy who's had a huge influence, not just in sociology. He wrote kind of across the spectrum. Beginning of the 20th century was still a period where even specialists, economists, sociologists, what have you, still tended to write sort of outside of the boundaries of their own disciplines. That happens less today. It's not gone, but less. Weber he was a German thinker, a PhD in law, but professor of government sociology, political economy. Again, somewhat of a polymath guy, crossed disciplinary boundaries. He is most famous for a book that he wrote, you see at the top, called The Protestant Ethic in the Spirit of Capitalism, published in 1904. And in that book, he controversially, at least now, most scholars have more or less rejected the Weber thesis in this great book. There are a few that have revived it or have always held on to it. I still think there's something in it that's informative, even if much of it, is deserving of being kind of tossed out now. But what he had to say was that Protestant Christianity, and more specifically Calvinism, helped pave the way for capitalism. Basically, he's saying it's one of the causes of capitalism because the Calvinists' work ethic and their religious ethic made them sort of perfect capitalists, and that without that, sort of accidental collision between already existing values stemming from their religious practice and a new system of economic relations, that capitalism might not have happened, or might not have at least taken off and exploded as it did. I still think, again, there's something to at least strands of this argument, if not the whole thing. But his, I think, single most influential concept isn't anything in that book. It's his concept of disenchantment. And there are plenty of other thinkers, even Durkheim, though he, Weber coined the phrase disenchantment. I don't know if Durkheim even used the phrase, but in a sense he was getting at something similar. Weber believed that the modern, rationalized, industrialized world, everything is calculated, everything is methodical, everything is kind of technical, science, politics, economics, law, a lot of technocratic approaches to those subjects, and as they're applied in reality, everything's bureaucratic, technical, efficient, predictable, machine-like, and it has been incredibly positive, according to Weber, in many ways, in terms of material comforts and standard of living and prosperity. It was required to do all those things, but it does have its limits and has its downside, and that's what he refers to as disenchantment. And I love the word disenchantment because it stems from the word enchantment, which I love. I love it because I think he describes something perfectly here that was indeed a problem. And along with the bureaucratic, technical, efficient mindset, we also have, in the late 19th, early 20th century, more and more Europeans less able to believe in traditional religion. How much those two things are linked is open to question, but I think it's pretty clear that they are linked to some degree. But the world before all of these industrial, modernizing, rationalizing changes was more enchanted. In a sense, it was more magical. People still had beliefs that might not have been rational. They might not have been, provable in a scientific way. But nonetheless, they held beliefs that helped them to get through their day and get through their life. And the world had a certain sense of mystery and in a sense magic to it, a poetic sort of sense, a metaphysical element to the world. And what Weber, Durkheim in his own way again, had seen is that it appears that the modern industrial world has destroyed that, and has destroyed the capacity to believe in anything magical, anything spiritual, anything that's sort of outside of the realm of, well, we can't put that into an equation, so it must not be important. Weber, unlike Durkheim, just thought this is a hard, brutal truth that we're going to have to own up to. So he's a little bit more depressing because Durkheim was at least looking for and found some potential solutions to the problem of disenchantment. Again, that's not his word, but it's more or less the same sort of problem they're dealing with. But Weber just said, sorry, we're going to have to tough it out. Not that he was necessarily wild about it, but he didn't see any way to get back the enchantment that was lost. So disenchantment is here to stay, and we'll have to just deal with it. And it's just the hard truth, the way that the world has unfolded. It's tough, a tough break. He talked about iron cages in his work, in taking away those illusions, myth, magic, mystery, replacing them with bureaucracy, efficiency, and so forth. That human beings in society has stifled individual autonomy and brought self-enslavement. This is the phrase "iron cages" that's was used to describe all of that. So he does paint in many ways a gloomy picture of the modern industrial world and what it does to human beings individually and sociologically. The Protestant work ethic we've really already talked about. He did also in his great academic career warn of charismatic leaders that were trying to return to a world of enchantment. And that sort of recognized that people had a yearning for a re-enchantment of the world, even though Weber is saying it's not possible. So if some charlatan comes around and tells you that it is possible, right, he's selling you a bill of goods. He's a demagogue, some sort of cult-like figure, trying to get you to follow them. So especially in hard times, he says people are can be easily bamboozled by this. So he, throwing down a word of caution so that people, are prepared for this kind of thing. He thought that passion and reason must be combined, and passion is a good thing, but needs to be always directed by reason. So it was in some ways a prophetic warning about charismatic leaders that wouldn't take too long to show up on the European scene. He said on the left in this well-known quote, "It's horrible to think that the world would one day be filled with nothing but those little cogs, little men clinging to little jobs and striving towards bigger ones. This passion for bureaucracy is enough to drive one to despair." So he wasn't necessarily wild about what he was describing happening in the world, but he didn't really see a way around it or out of it. That's why Weber, by the way, is a tremendously important figure in European intellectual history. He was influenced by Karl Marx, and he thought that Marx's focus on class conflict was important, much of it true. Where he criticized Marx, and I think showed himself to be a better thinker than Marx, is that he saw the limits to Marx's laser-like focus on class conflict. And so it was, class conflict is important, and Marx has offered us a body of thought that helps us to think it through more carefully, its problems and possible solutions, but he didn't include any other types of conflict. Like I said when we spoke about Marx last time, that he didn't deal with ethnic conflict, religious conflict, etc., because he didn't think it was important, or he thought it was subservient to and derivable from class conflict. Weber didn't agree, so his analysis of conflict is much more varied and much more nuanced for that reason. But Durkheim, we have looked at these two figures back to back, both sociological greats. But I liked Durkheim better just because he was trying to find solutions, even if they were in some ways quasi-backward-looking solutions. He was trying to find creative solutions to end the problem of what Weber describes as disenchantment. Durkheim was, in essence, trying to re-enchant the world to some degree, not to the point where science and reason were put to bed, but to sort of even things out some, bring balance. Now get to the birth of modern science. Not all Western civ texts or classes deal with this, but I like to, one, because I'm very interested in science and I think it's important to understand at least the basics and how it fits into our world and our understanding of the world, but also because we did a whole unit on the scientific revolution, and I like to kind of update us, see where science is now, or closer to now. I'm going to quote Lawrence Krauss a great deal in a brand new book called The Greatest Story Ever Told So Far, which is about modern physics. And Lawrence Krauss is one of the top physicists in the country at Arizona State University. He's interesting to read and listen to. If you see him on TV, he's pretty full of himself. Can be, quite arrogant, but he's got a good sense of humor and he's a good writer. So I do like this book. So I'm going to quote it to help elucidate some of the things that we're talking about here. So just to start with some choice quotes from this book, Krauss just kind of set up what we're talking about in terms of modern science. We already have a background in this, or a foundation, some context, since you're all experts on the scientific revolution because of me. No, because of your hard work in this class. Modern science seeks to know the physical world beyond our senses, the world that helps us understand how things behave the way they do, rather than why. Remember that? We talked about that before. Science deals with the how. It doesn't deal with the why. Now, Krauss isn't going to admit this because he's a hardcore atheist, but that does leave the door open with the why for God or some type of sort of supernatural or sort of top-down intelligence to explain certain aspects of the universe, or at least speculate on those aspects of the universe. He talks about connections between otherwise seemingly disparate phenomena, more than any other single indicator being the hallmark of progress in science. So when sort of two things that were never seen as related to each other at all come together in some scientist's work, or some sort of lucky find, which does happen sometimes, wow, these two things are actually connected and related. He calls that the hallmark of science. We cannot understand that hidden world with intuitions based solely on direct sensation. That's another way to say that a great deal of modern science is counterintuitive. You wouldn't get there just by sensory perception alone. Going back again to our look at the scientific revolution, we saw that Copernican theory is even such. It doesn't seem like the world is moving. It doesn't feel like it's moving. There's no wind blowing us down, and we're not. It doesn't feel like we're going at any speed at all. It feels like we're still. Therefore, we're still. So just like Copernican theory was true, but sensory perception was not going to get you there. Modern science, that's been more and more true of it ever since, increasingly so. Why should the universe exist in a way that makes sense to us? This is a good question too, which I also think can and should, not necessarily in this context or in scientific circles, but can, should, and I should say does lead to metaphysical speculation as well. But Krauss, isn't the type that's going to go there. But I think he's right about this. We're incredibly fortunate that the universe exists in a way that is ordered, and that we have brains and minds that can understand at least some of the order of the universe. It seems certainly theoretically possible that we could have been, we could have started as a species, evolved into what we are today, and yet have no clue what much of the world is about. We're not even be able to explain the hows, let alone the whys, because it's possible we wouldn't have the tools, the capacity, the senses, the brains to be able to do it. So, I mean, since there are animals that can't understand the universe, it's perfectly possible that we would have been ill-equipped to deal with it. One might say we're unlucky to be able to understand the universe, but it is quite amazing that we are. He goes on, the purpose of science is to make people uncomfortable, to make them uncomfortable. So to sort of shake things up and sort of lead where the evidence and the truth leads us, regardless of what people think about doing it. And certainly we know in our class, Copernicus in his day, Darwin basically in this day, certainly made people uncomfortable. So according to Krauss, those two and many more were doing their jobs. There were two modern revolutions in modern physics right around the same time. Albert Einstein on the left, involved in both of them. The famous quote from Einstein about saying, believing that God doesn't play dice with the universe, meaning he didn't think it was necessarily all random. Though that's not a profession of a belief in God, but he did think that really what this is about, he's sitting next to Niels Bohr, one of the all-time greats in the history of science as well, and they, in a sense, had disagreement over Bohr's and other physicists' commitment to and belief in quantum physics, quantum mechanics, quantum theory. Einstein spent most of his career, his key insights in his two theories of gravity, the special and general theories of gravity, relativity, both of those came early in his career as a young man. Physics is a subject where it's quite common for people to sort of do their most creative work in a short amount of time, particularly early in their careers, and then not have anything nearly as brilliant ever after. But Einstein spent much of the rest of his career not putting forward theories, but trying to debunk quantum physics. And they worked together all the time, and they were friends to some degree. You see them sitting together here. But Einstein was constantly working to undermine quantum physics, not in a awful way. In fact, I think it's probably true to say that he helped Bohr to clarify his own thinking, because he had a sort of a built-in critic in the brilliant Albert Einstein, constantly challenging him and forcing Bohr to explain more and more things. Because Einstein would put some serious roadblocks up at times, and Bohr would think, "Ooh, that is a problem. How can I salvage quantum theory? With that question or series of questions he asked me." And that would, in a sense, inspire him to think harder and sort of look into it more carefully. But the two pillars then of 20th century physics, and one could say of 20th century science, are relativity from Einstein and quantum mechanics coming from Bohr, Heisenberg, and others. Another current physicist named Carlo Rovelli, an Italian, obviously in 7 Brief Lessons on Physics, a very readable book and a short one, but he is a physicist by trade, says the two pillars of 20th century physics, general relativity and quantum mechanics, could not be more different from each other. Both theories teach us that the fine structure of nature is more subtle than it appears, but general relativity is a compact gem conceived by a single mind, that of Albert Einstein. It's a simple and coherent vision of gravity, space, and time. Quantum mechanics, or quantum theory, on the other hand, has gained unequaled experimental success and led to applications that have transformed our everyday lives. The computer on which I write this, for example, but more than a century after its birth, it remains shrouded in mystery and incomprehensibility. That's for sure. Hardly anyone understands quantum mechanics. A lot of times the physicists, quantum theorists themselves, who will admit, we don't really understand this. The problem is the math tends to work, and the experiments tend to come out showing that it's true. And what's often true is, at least by traditional standards of thinking and rationality, crazy. It doesn't make sense. But what they're often saying, quantum theorists, quantum physicists, is the math shows that, it doesn't make sense. But it's true. The experiments show that it doesn't make sense, but it's true. Which is a bizarre situation indeed. So I think it's in physics that the greatest triumphs in science have happened, going back to Isaac Newton and coming forward to these two great kind of twin theories at the same time, beginning of the 20th century. I'm not saying other scientific fields haven't made great strides today. Brain science, neuroscience, genetics. Some of these fields are sort of leaping ahead, but I still think they're not on a sound footing overall as the basics of the three major revolutions in physics, all three of which, after this lecture, we will have looked at in this class. We have to backtrack a little bit. This, I guess, can be seen as context, but this is the heart of everything that comes next. Both relativity and quantum mechanics and theory could not have been possible without the work of these two guys, or somebody like them, Michael Faraday on the left and James Clerk Maxwell on the right. They discovered basically what we call now electromagnetism. It's a great example of what Krauss was saying in our earlier quote, when he said that the hallmark of science is when two things come together that were previously thought to be unrelated to each other, electricity and magnetism, and boom, did this cause. This is an incredible series of exciting discoveries, because they were so seemingly out of the blue and unrelated. So this was a bombshell. Krauss says the mathematical framework on which all of current theoretical physics is built, meaning electromagnetism. Michael Faraday was basically a self-taught physicist. I come from a working class background, and so he kind of added the experimental element to this and concluded that electricity and magnetism, sure enough, were related, closely related. Electricity could induce magnetism, and magnetism could induce electricity. And I don't have time to go into all the ways that this has been extremely important and beneficial in understanding and manipulating our world, but indeed it has. These forces are surrounded by fields, according to Faraday, emanating outward from the forces. Maxwell added the theoretical gloss to it, mathematical precision, providing a mathematical elaboration of Faraday's explanations of electrical and magnetic phenomenon. His electromagnetic theorizing culminated with his treatise on electricity and magnetism in 1873. So these guys are going back a ways, but they're laying the groundwork for the two great revolutions that we're about to get to and already introduced. In 1844, middle of the century, Faraday gave a lecture on the nature of atoms, in which he said, interestingly, Instead of treating an atom as a physical entity that lay at the center of a web of forces and was the reason for the existence of these forces, Faraday proposed that it made more sense to regard the web of forces as having the underlying reality. So the forces themselves that are the reality, with the atoms only mixing as concentrations in the lines of force making up the web. In modern terminology, the field of force. Faraday made it clear that he wasn't just thinking of electricity and magnetism. Magnetic, electric, and gravitational lines of force filled the universe and were the reality which the seemingly material entities that make up the world are interconnected. The material world was simply a result of knots in the various fields. In a way, he's saying it's the fields of force more than the physical objects that we think of as the reality of the world that are the actual reality, or they're the more important reality. So a lot of mind-blowing thinking going on here. So how does this fit into changes in European thinking? Since our whole unit is about the change from the great confidence around mid-19th century in Enlightenment and science and reason and all that, and the change then towards the end of the century into the next century to a much more pessimistic and anxiety-producing sort of viewpoint, worldview. Well, science is sort of on both sides of this. Certainly, the discoveries being made here are, clearly within the realm of, science and scientific method, progress, reason, all of those things. That's for sure. However, so much gets learned here that, and this is, I think, increasingly true even today in many, many fields, especially physics, biochemistry, other related subjects, that we're learning so much at an astonishing rate that in some ways what it's doing is just causing us to realize how much we don't know. That, for instance, something that is seemingly to scientists as simple as the cell is extraordinarily complex, and we're learning about sort of more and more elements of cells that make them even more complex than we knew a year ago, 10 years ago. So in some ways it's confusing. I mean, confusing is the wrong word. It's a complicating factor because it does fit the overall general move of science, is in a greater sort of rational direction, letting scientific principles and method dictate, and it's moving to better and greater knowledge and understanding. But in some ways, it's also making things more confusing, and in some ways more scary. And even the most famous of the theories here, relativity and quantum mechanics, this frightened a lot of people, a lot of them, especially the latter. To the extent that these theories were digestible and known by the general public, wasn't too much or too many people, but it wasn't necessarily comforting to someone that wasn't a scientist to know that scientists are saying this or that about the world. We'll get to Werner Heisenberg and we'll see an example of that. Electromagnetism itself has had tremendous impact on our world in a technological sense, primarily in our standard of living way of life. Krauss saying about Faraday, perhaps more than any other scientist of the 19th century, he's responsible for the technology that powers our current civilization. Faraday's discoveries allowed us to power and create our civilization, to light up our cities and our streets, turn our electric devices. It's hard to imagine any discovery that is more deeply ingrained into the workings of modern society than electromagnetism. So it's seen as to scientists as pretty basic today, but at the time it was an astonishing find that led to all of the fruits that you see here. Not that some of them don't have a lot of problems with them as well, since there's a mushroom cloud there in one of the little pictures. So there's certainly a downside to it. But this is an astonishing array of scientific and technological achievements that have had, applicable, everyday use to human life and society. Einstein himself, probably the most famous scientist in world history, and one of the greats, again in the same conversation with Isaac Newton. Niels Bohr is probably in that as well. Maybe one or two others, and probably no more that are that high in the pantheon, or in the pantheon at all, of scientific greats. His two theories of relativity coming 10 years apart: the special theory of relativity coming in 1905, the general theory of relativity coming in 1915. Special relativity basically explains, and I'm keeping it very simple, partly because I'm not a scientist or physicist. I've read The Idiot's Guide to Physics. No, I've read more than that, I think you can see, but I'm far from an expert on this, incredibly difficult subject. But more or less, what special relativity says, in a way that sort of how to say this, is useful for laymen like me to know, is that matter is basically energy waiting to happen. There's a gigantic amount of energy in every material thing, and so that wasn't at all known before, but it wasn't very well known, and it wasn't sort of really known sort of how before. But radiation converts mass to energy very efficiently. The speed of light, this comes up in special relativity as well, was constant, and light was crucial to understanding the universe. All things that were part of special relativity that ended up being correct. But the bigger, more blockbuster theory is this theory of general relativity, which special relativity helped to set up. But this is bigger. Space and time are not absolute, but relative, when they're unified at the same time. Reality is what we can accurately measure where we are at a given time. But another person's accurate measurement of the same phenomenon from a different location is also reality. Both yet different observations are true. And this is part of space, or space-time as he called it, space and time being unified here. Gravity itself, this is maybe the most well-known part of general relativity, is the warping, bending, stretching, curving, distorting of space-time. The gravitational field is, as Professor Rovelli says, not diffused through space, it is that space itself. Or as Dennis Overby, in a much simpler way, says, gravity is the ultimate sagging mattress. So that gravity is pretty lumpy. Let's put it that way. We'll see a graphic of this next. Krauss, again, one person's magnetism is therefore another person's electricity. Back to the connection to electromagnetism. And what connects the two is motion. The unification of electricity and magnetism reflects at its heart that uniform relative motion gives observers different perspectives of reality. Motion, a subject first explored by Galileo, ultimately provided a key to a new reality, one in which not only electricity and magnetism were unified, but also space and time, which Einstein did in general relativity. This is sort of a famous experiment, or thought experiment, about to sort of show special relativity. And you can kind of look at this yourself, but the point is that the person standing at Y and someone in the train at X will perceive the same events slightly differently. With two lightning bursts apart from each other, one will experience them as simultaneous, the other will experience them sort of one after the other. So it was a thought experiment, and one that still is used to try to simplify how sort of things can be. They're actually describing reality, both both people are not wrong, even though they're contradicting each other about what they experienced. Now, I should say this. I was going to wait to quantum mechanics, but this is the kind of thing that, in the early 20th century, when an average person who's not a physicist, a mathematician, whatever, this is going to, likely, if they think about it for any time at all, it's likely to be disturbing. I mean, some people it's probably just fascinating, but to others it's kind of disturbing. They might just reject it. So that's garbage. These scientists are, what do they know? It's common to say that today, but you can see how this could be disquieting and cause people to think, wait a minute, does our universe even make sense? This doesn't seem to make sense. Modeling the universe. This is a model of the universe according to the theory of general gravity, so that the universe gravity itself gets sort of bent by objects, stars, planets, and stuff out in space. Now we get to quantum theory. How to picture an atom? Don't try, as has sort of often been said in one way or another in quantum mechanics. Niels Bohr on the left, already mentioned. Werner Heisenberg on the right, as a young man. Both giants in physics and quantum theory. Heisenberg's uncertainty principle in an essay, that's the name of the essay, the principle coming out of it, published in 1927, was the example I was going to use of a way in which the scientific theories and ideas of this period were mind-blowing to lots of people, and did have some influence, as scientific theories often do, on the world, even outside of science. He was showing that in science, and the essay is actually about that. It's not just about, though he was a physicist, it's not just about physics, but it's about how that can be applicable to the outside world. But there's sort of a radical uncertainty in not being able to know the position of electrons in quantum theory. We can kind of predict where they are. Sometimes they could either be here or there or in both places at the same time, simultaneously. And yes, that appears to be true. So this is the kind of stuff that's would have been mind-blowing to the people when they first learned it, if they weren't already really kind of prepared for it. So some of the startling findings of quantum mechanics, I'm repeating my own words really, electrons can only jump between one atomic orbit and another. Quantum leaps, all right, that's where the theory, or the phrase comes from. Cannot know the velocity and position of an electron at the same time. So you can't know the velocity and position at one at the same time. You can only use probability, the uncertainty principle. Even observing such phenomena itself gives a misleading picture of what is truly happening. So even observation causes problems and can distort what we see or think we see. Lawrence Krauss, again, my go-to thinker here, far less intuitive. He's going from Einstein to quantum theory. Far less intuitive was the next discovery, which was that on very small scales, nature behaves in a way that human intuition cannot ever fully embrace, because we cannot directly experience the behavior itself. The quantum world defies our notion of what is sensible or even possible. It implies that at small scales and for short times, the simple classical behavior of macroscopic objects simply breaks down. Coming to grips with the strange behavior of quantum mechanics means often accepting the seemingly impossible. But whether we like it or not, experiments tell us it is so, which I kind of already said as well. So this is mind-blowing stuff indeed. I should say this too, probably already surmised, that Isaac Newton's, grip on science was only loosened by relativity and quantum theory happening kind of as a quick 1-2 punch. but that's even, I think, somewhat overstated often, because for almost everything except particles, of the smallest kind, and if we're getting to cosmology and sort of, it's now the Big Bang, wasn't that yet, but it's only in those sort of special realms that Newtonian mechanics breaks down. For any everyday stuff, Newton still holds up to this day. So gravity still holds up, except for these very kind of esoteric, subfields within physics. There are many practical applications to quantum theory, from bombs to medical use, to technology, quantum cryptography, lasers, quantum computing, and on and on and on. So even this has way more practical value than you might have thought. Even before you got to this slide, you might have thought, well, who cares? What is that? How does that help us? Well, here it is. We now get back to thinkers in the classic sense, not that scientists aren't thinkers, of course they are, but novelists, writers, intellectuals. This is kind of more the humanities, not the sciences or social sciences. The great novelist Franz Kafka is someone I believe that must be dealt with in this unit and in a class, Western Civ. Kafka, also one of my favorite writers. Much of his, basically his fame came after his death posthumously. He wrote The Trial, 1914-1915, during World War I, but it wasn't published until 1925, the year after he died. He didn't live that long. He was a Czech writer from Prague, with a Jewish background. Died of tuberculosis young, as so many did in those days. His novels depict a sometimes surreal world with no order, stability, or traditional values, to a terrifying degree. And I wrote that, so I think that's true. Characters often caught in a bureaucratic web they can't control, dominated by extremely cruel use of unseen, unvague, sort of abstract and distant power. In The Trial, a great book, Joseph K., the main character, he has a tendency, Kafka that is, to have his characters not have full names. I think it's a way to kind of intentionally depersonalize the novel, to give it sort of an extra, inhuman feel to it, because the books are a lot about how larger, uncontrollable forces. I don't mean natural forces like earthquakes and hurricanes, but how sort of social forces, economic forces, and so forth, can catch individuals in their webs, and just utterly annihilate them and bewilder them, while doing so. In The Trial, the main character is arrested after being questioned a number of times, and he never knows why he's being arrested or what for. And even after he's incarcerated, he still is never told, and never understands what he's been arrested for. And he ultimately pays the ultimate cost in the end for committing this supposed crime, and never finds out what happened, why he's even there. So a human being, a fictional story of course, but a human being utterly bewildered by forces that are much greater than him, that are chewing him up and spitting him out. So he thought people, at least comes across in the writings, that people are playthings of these sort of larger, sometimes irrational forces. They can't understand, but those forces consume them. He deeply described the alienation and isolation of individuals in the modern world. In that sense, one could see him, I think, as a successor to the Romantics, who we know wrote and thought a great deal, or painted a great deal about human alienation, isolation in this big, unfeeling world. Peter Gay, a now deceased historian, an expert on the Enlightenment, but also has written on modernism as well, European historian, says in one of his books called Modernism, the appalling fates of Joseph K. and other of Kafka's protagonists are awash in disconcerting images, but the burrowing after deeper emotional realities seems to be largely absent from his writings. His leading characters are little more than marionettes in the hands of irresistible forces. They may protest, they may seek to reverse the irreversible, but they have little, if any, inner life. Whenever Kafka had an opportunity to comment on the science of mind, he showed his disdain. Quote, "There's no observation of the inner world as there is of the external world. The inner world can only be lived, not described. Psychology is impatience." So his characters, unlike what you usually get in novels, are not sort of filled with descriptions or an attempt to understand sort of what's inside the minds and emotions and of the characters. But that's partly because he wants the reader to focus on the outside forces that are crushing the individual to sort of give them the full sense of how crushing they actually are. Jean-Paul Sartre, the most famous of the existentialist writers. Here in this segment, yes, I'm talking about Sartre, but I'm using him to understand the influential philosophy known as existentialism at the same time. So some of this is me using Sartre, the most famous of the existentialists, to understand the whole school of thought and philosophy. Sartre himself was from a middle-class Parisian family, graduated from the École Normale Supérieure, a top-notch university, to put it mildly, a philosopher, novelist, playwright, political activist, was a socialist, pretty strong socialist. For a time, he was quite enamored of the Soviet Union, as actually many intellectuals in the Western world were, in the United States as well as in Europe. But his political beliefs were always very left-wing. Not all existentialists were left-wing, but many of them were. The basic principles of existentialism expressed by Sartre and others. One, life has no inherent meaning or purpose. Existence does not come with prefabricated values. And as Albert Camus, another one of the great existentialists, said, life is absurd. That life is absurd. They believe that you must create your own meaning then by making choices and facing the consequence of those choices. So you have to choose. You can't just sort of, you're not supposed to, if you're going to lead a fulfilling life, just supposed to sort of let life happen. You're supposed to make bold choices, but then be willing to face the consequences, good or bad. One of the fathers, sometimes considered the father of existentialism, was a Danish thinker, came earlier in the century, named Søren Kierkegaard. Kierkegaard wrote an impossible book to read, Either Or. It's very long. It also has there's no genre there. He just mixes all kinds of things together in this huge book. But it is interesting to pick apart or to read about and then find the passages that some literary critic has cited. And Either Or is a classic work of existentialism because it's just saying you make choices and it doesn't really matter which ones you make. There's kind of a grass is greener element to this. So one of the great passages from Either Or says, and I forget the exact way this is syntactically structured, but it's something to the effect: if you marry, you will what's the word? I can say the word. How does he say it now? I'm drawing a blank. If you marry, you will regret it. If you don't marry, you will regret it. If you marry or don't marry, either way, you'll regret it. And then he goes on to yet something else, and it has that same structure to it. You'll regret it. You have this choice or that choice. Another way, you'll regret it. So you see, no matter what we do in life, we're going to have doubts and regrets. So just choose, and don't just live with your choices. In a sense, don't reflect too deeply on it, because it doesn't really matter in the end. The choice was going to have the same, many of the same repercussions anyway. Also, that to the existentialists, human beings, as Sartre said, are condemned to be free. So making your own choices, 3 kind of leads from 2, forces you to be free. If you don't make your own choices, someone else is making the choices for you. Society is making the choices for you. So you're not at least exercising freedom, even if it's available. Condemned to be free. There's a psychologist, Eric Fromm, I think right near this time, that a little bit later, but wrote a book called Escape from Freedom. And he was more or less an existential psychologist, so it fits here. And what he meant is that most human beings escape from freedom. Most human beings, as Sartre believes, at least according to the existentialists, think of it as that we're condemned to freedom, to be free. What do they mean? Well, freedom has anxiety that comes with it. Choices require you, right, to be the decision maker. You and you alone have to make the choice at times. And so there's a lot of pressure here, and a lot of commitment and responsibility that most people don't want to face. So they just want to sort of have someone else, society, the customs, values, conformist expectations in society to sort of decide things for you. They'll probably always say they want to be free, and probably don't understand the degree to which they're not making free choices. But nonetheless, the existentialists think that freedom is extremely important, but most people don't really want it, no matter what they say. We're alone in the universe. The universe is indifferent to our needs. Death awaits us without salvation. And of course, this fills us with anxiety and dread. Nausea, as Sartre called it. In fact, he wrote a book called Nausea about this existential dread of existence, or the end of existence. So that's pretty dreary, and it also mimics the Romantics in certain ways. They thought or believed that thought, to have any value at all, must be put into action. You must get involved actively in your life, in the world. So another sort of corollary of making choices, you have to be active. You have to make choices, and I'm going to get out there and go do this and commit myself to that. And many of them, the existentialists, as I said, were left-wing in their political views. Many of them were atheists, though Soren Kierkegaard was a Christian, kind of a Blaise Pascal type Christian, who takes the classic leap of faith because he didn't think you could actually prove that God existed or know for sure. So you just sort of take the leap and say, I'm going to hope God's there, and take the leap. But most of them, Sartre included, Camus included, were atheists. You can see many of these guys were French as well. They're not all. But I would say this: the overall philosophy of existentialism has its, I think, merits. As a philosophy to live by even today in some ways. But in other ways, I think they're sort of, they are part of a work of deconstruction that has a dangerous side to it. Make up your own values as you go along. It sounds nice to have that kind of freedom, but that gets somewhat Nietzschean, somewhat nihilistic. Wait a minute. If everybody gets to make up their own values, aren't we going to have chaos and anarchy? I think the answer is quite possibly yes. So this is just to sort of put things into perspective by using the thinkers we've been talking about. This is quite different than, say, Emile Durkheim. the sociologist, also French, who's saying we need values, we need some certainties, and that's the problem with the modern world, is that we're losing them, and so we need to either get the old ones back, which you didn't think was possible, or create new ones that are enough like the old ones that it works. But we need some solid foundational principles and guiding values, and to come along for the existentialists to come along and say that, oh, there are no inherent values, life is absurd. Some were bound to think was dangerous, and some today, I mean, I'm included among them. I'm attracted to existentialism in a lot of ways. I've read a lot of Camus and Sartre, and they're very interesting thinkers. I think some of this is a philosophy to live by, but not all of it. It does seem to have too much sort of relativism isn't in it. Not enough meat on the bone that people can kind of grab onto and feel secure, as an individual or in a community. George Orwell. I can never refrain from including George Orwell here. One of the great 20th century novelists and brains. This guy, a British writer, started his life as a journalist, his career as a journalist. Eric Blair was his real name. Orwell was a pseudonym. Born in British India, middle-class background. He also died early of tuberculosis. His most famous works, Animal Farm, which he published right at the end of World War II, and 1984, which he published in 1949, which is a confusion, and two great books. 1984, in my view, is a must-read on anybody's sort of lifetime reading list. At some point, read 1984. Orwell, I generally, honestly, don't like political novels. I like serious novels. I don't read junk novels, but I don't really like ones that are sort of expressly political. But he's an exception, and it's important work. So Orwell was deeply committed to reason, freedom, human dignity, and he was greatly concerned about governments that abused power, particularly the totalitarian regimes that arose not in England but in Europe during his time, especially the Soviet Union and Soviet communism. His sort of overarching theme, at least in his later work, was that totalitarian regimes, claim the right to rule because the masses, as leaders saw it, were unfit to rule themselves. Modern dictatorships, however, do not even pretend to govern in the interest of citizens. They openly promote and carry out domination, torture, and humiliation as a form of pleasure. So in Orwell's view, at least previous authoritarian governments said, at least paid lip service to the idea of ruling in the interest of the public, but totalitarian regimes don't even make the pretense of doing so. And in 1984 especially, he explores and takes totalitarianism to its logical conclusion. So it's a dystopian novel. Right? Utopia is a perfect world. Dystopia is a perfectly nightmarish world. So he takes totalitarianism to its logical conclusion. Not only does the political party that has power, actually it's in England in the future, 1984, which at the time was in the future, but it's a totalitarian dictatorship in England. But not only are you not supposed to do anything that the party and the government doesn't want you to do, you're not even supposed to think it. And there is a thought police. That phrase has entered our lexicon, but it comes from Orwell. So they're finding ways to even control what you think, brainwashing and other kind of futuristic methods. He said in one passage, "The party seeks power entirely for its own sake. We are not interested in the good of others. We are interested solely in power." This is one of the leaders of the party government talking. "The real power, the power we have to fight for day and night, is not power over things, but over men. power is in tearing human minds to pieces and putting them together again in new shapes of your own choosing. In a famous scene in 1984, the main character, who is a subversive, he's trying to, with great danger, trying to undermine and fight against the totalitarian regime that he lives under. But he gets caught and imprisoned and tortured by kind of the arch villain of that story, who's a government official. And his torturer says at one point, "You want to see a picture of the future? Imagine the heel of a boot stomping on a human face forever." That's your image of the future. So Orwell, though it was a fictional future Great Britain he's writing about, it's clear that most of this was aimed directly at the Soviet Union under Stalin and the brutal, nightmarish communist regime that existed there. However, it is interesting to take some of his themes, doublethink and these kind of things, and apply them to democratic societies and liberal societies like Great Britain and the US. So I do think he meant that too, but he primarily was talking about the extreme dangers of totalitarian systems like the Soviet Union, the real ones that already existed or had existed in some cases. Our one artist or painter on the list, the inimitable Pablo Picasso, Cubism and Modern Art. Peter Gawe, quoted before in his book on modernism, said about Picasso, "Whatever he etched or painted became a work of art under his hand, an act of free translation of reality, a tribute to his genius. The uniformly recognized trajectory of his work, that much discussed succession of Picasso's styles, was in no way predictable. Each of these styles would have been productive enough to guarantee Picasso prominence in the forefront of modernist art, but one of them, Cubism, calls for particular attention. For more than all the others, it made a momentous modernist statement about the autonomy of art. Intent on making works of art that would not let their viewer forget their distinct essence as human products, shattered surfaces that in nature belong together, and reassembled fragmented reality by transforming a curved object like a woman's breast or a man's cheek into some strange geometric contour that resemble virtually nothing." This is, you see one of his famous pictures, the three musicians on the right. Picasso had the talent to be able to paint sort of in a classical style where you can see human figures and nature in ways that are quite realistic and quite beautiful. We know because we have them. He did them. But he was very into experimenting and modernist art, Cubism, what he's most known for today. It is brilliant. Not a lot of beauty in this, I would argue. I'm more of a traditionalist when it comes to art. You're probably not surprised, but my art needs to have beauty to it. I mean, you can argue there's a certain amount of beauty to this picture, and others like it, but I like sort of more classical beauty in art. But in recent decades, kind of ever since Picasso and Cubism and modern art, you're kind of considered lowbrow or not sort of elite if you don't if you like pretty pictures instead of modern art. So there's kind of an elitist element to modern art today. You just don't understand it. No, I understand it. I just don't really like it. But again, I'm not saying that necessarily about Picasso. His work is certainly interesting, for that matter. And there's a lot of interesting thought behind his work as well. Great artists are sometimes great thinkers as well, as we know from the Romantics that we already looked at in a previous unit. So Picasso, it says he was intent on making works of art that could not let the viewer forget their distinct essence as human products. So in a sense, he's separating human beings from the natural world by painting the natural world and other human beings in ways that sort of make them look quite different than him or you or me. So I find that interesting too, because it's in a sense saying human beings are sort of unique, and we need to focus on that more. There are even religious implications to this, whether that was his intention or not. That there are. So Picasso is a great example of the turn to the modern in ways that challenge tradition. That in some ways also to connect as many threads as possible here before we retire. That he's sort of connecting threads to this disorienting, right, sort of disillusioning period that Europe is going through in the late 19th, early 20th century. Although he lived way longer, but nonetheless, his modern art or contribution to it, and others sort of in the same vein or same school, are reflective of and in some ways attesting to the uncomfortable changes that have taken place, the disillusioning, sort of sometimes despair-producing changes that come right in the late 19th, early to mid, we could say, push it forward a little bit, 20th century.